Join with computer audio. Okay, cool. All right, with that in mind, let's go over here. And Anderson is absent. Grayson is absent. Davis is here. Graven is here. Morgan, not here. Wraith, you are here. Oglesby, you are here. You're so quiet. I didn't mark you absent last time because I didn't notice that you weren't here. It was bad. You need to talk more. Thank you for saying nothing. Okay. All right, and then Rambo. Hi, Rambo. How are we doing today? Excellent. Okay, so with that in mind, we will move on from there. Okay, so let's go back over here. Okay, so the first thing it said to do was find the equation of all four lines, right, guys? Okay, so to find the equation of all four lines, y minus something equals something, x minus something. Do you agree? Did it say to put it in a specific form? So then which form can you put it in? Any form you want. Be like, no, I love standard form. So can you use these 2 points to make that line right there? Could you use these 2 points to make this line right here? And these 2 points to make this line right here, and the last 2 points to make the last line over there. Does that make sense, guys? So that's question number 1, right? Question number 2 was, and how would you know if they were parallel, perpendicular, or neither? You look at the slopes of each of these lines. Once you found them, and go same, 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 different, different, whatever. Okay, cool. What's step 3, or what's question 3? So we're good there, right? So I'm going to use those 2 points, these 2 points. We're going to do 4 distance formulas. Do you agree? Okay, I'm pretty specific on these guys, okay, buddy? Appreciate it, Mr. Lowe. 4, step 4 was?
What can you tell me from number 1, number 2, and number 3 of any pairs of lines?
Okay, so what's that?
About it.
Okay, so for example, are any of them parallel? Are any of them perpendicular? Are they the same length? Are they not the same length? Get the idea? All right, what's 5 say?
Find the length of the diagonal.
Okay, how do I find the length of the diagonal? First of all, what's a diagonal, guys? Somebody besides Davis, what's a diagonal? Oh, boy. Wow, okay. Which points might a diagonal connect? Just make a guess. It's like there's 4 of them up here. What point would I connect to make a diagonal to that guy right there? Ooh, guys. Diagonal, right? Goes from one corner to another corner. So you would find the distance of that, correct? Then what could I do? Distance of that, right? Davis, what's next? Midpoints of the diagonals?
What can you tell me about the large angle A?
Oh, okay, now which one is A? Well, that's when you graphed them, you should have labeled them, right? So here's the question, like angle A. What might be true about angle A and that angle over there? What might be true about them according to my picture? Graven, what might be true about this angle and this angle? I'm not saying it is, but what might be true?
Congruent?
They might be congruent. Yeah, they might be. I don't know. We're going to have to look, right? Okay. So what's the next question there, Davis? Okay, so what formula would I use for that? I would think so. All right, are we up to question 9 yet?
No, find the equation for each side.
Okay, so we can find the equation of each diagonal, correct? Because it's just a line. Is that right? And then number 9. Okay, number 9 I'm leaving till tomorrow. okay? Number 9, I'm leaving till tomorrow. And number 10 is,
Oh, there's an arrow behind it. What shape is this?
okay, and then, there you go. Okay, so that makes sense. So could you finish this for tomorrow? Cool, do that. Does that help everybody else? Most talkative class I have. All right, here we go. If these two lines are parallel, I need to know, what are those two angles right there? What do we call those? Now, let's go to our slideshow. They did like this all year, it's great. Let's go to our slideshow, and slide number 7. Nope, slide number 8. Slide number 8. All right, and go to just go to one of the note pages on slide number 8. Okay, these are your choices. Slide number 8, go to the note page. All right, what are some of the choices for how we might label angles? Well, what's the first one up there in the top corner? What's it say, Rambo?
Which corner?
Let's go with the right corner. So vertical angles, are those vertical angles, guys? Up there. Are those vertical angles? No, because where are vertical angles? They are across the vertex from one another. Like, look at angle 1 and 4 on the picture. Angle 1 and 4 on the picture. See those? Now, down in the first red ones, what's angle 1 and angle 8? What's listed next to 1 and 8? AEA. What does AEA stand for? Sounds like some folks need to go back and rewatch that section of the slide deck, huh?
Which one are we looking at? This one?
No, slide number 8.
Oh, I'm not that. I don't know.
There you go.
Oh.
Which either one would be fine. So, what does AEA stand for, folks? Oof, rough. And then we have AIA. And we have COOR. We have vertical angles. We have supplementary. We have linear, pair. What else do we have? We have complementary. We have adjacent. Have all of those been in your slideshow already? Yes or no? Yes, no, yes, yes, and yes, good. So if you're not answering, it's either A, you're choosing not to, or B, you don't know. One of those two things is true. Neither of those, what's that? There you go, good job. Neither of those things is acceptable, so you may need to go look back and rewatch that section. Does that seem reasonable? Yes or no? Yes, excellent, good. Now let's go to your worksheets that I just gave you. So let's go to these guys right here. Let's go to this one, right here. Okay? Now, what do you think AIA stands for according to the directions right here on this page? Rambo. Alternate interior angles. What does CORR stand for? Their ovals be. Good. And what does AEA stand for? Perfect. Okay. So all you have to do on page 1 is literally choose one of these 3 things that match up with the picture. So question, which one of these 3 is that right there? Is that alternate interior, alternate exterior, or corresponding?
I'll throw a guess.
Throw a guess.
Interior.
It is not alternate interior. Now, here's how I know it's not alternate interior. And here's how you'll know. You ready?
There you go.
What's the word interior mean? Oh, no, no, no. If you have interior designer, if you're the department of the interior, what does interior mean? Help him out. What's interior mean, guys? Inside. Does that make sense?
Yes.
Okay. So interior would be all this area in between the two parallel lines, correct?
Yes.
So why would these two angles not be alternate interior angles, do you think, Mr. Lowe? Well, because one of them is not, that's right. Now, how come it's not alternate exterior angles? Well, because exterior means, that's right, so there's one on the outside, yay. Oh, but that's not on the outside, is it?
So it's corresponding.
So it has to be corresponding, and here's why it's corresponding.
One's
Because
outside and one's inside.
maybe, are both of them on top of their parallel line?
Okay.
And are both of them over here to the right of their parallel line? Are they basically in the same spot on each parallel line? They correspond to one another. That makes sense? Now you know, knowing half about it. Okay, now, Rambo, what are these? One of those three. No, Rambo's gonna go. She's 100% correct. Now, why is it alternate? One's on the left and one's on the right. And they're interior because they are, love it. Okay, so Isabel, then obviously the easiest question is left now. Now that wow, that's the worst picture ever. Now that they've all taken the rest of them, what's this angle and that angle then? Because they're both on the outside and they're on different sides of the transversals. That makes sense. Okay, now, by the way, vertical angles. Why are those vertical angles even though they're side to side? Why are these vertical angles even though they're side to side? They share a vertex right there in the middle. What's supplementary? Graven, what's supplementary mean? Add up to, ooh, or complementary. You could do complementary or supplementary. Okay, how about a linear pair? What is a linear pair? Makes a, it makes a line, correct? So for example, this right here is a linear pair. This and that make a straight line, don't they? By the way, if they make a straight line, what do? They add up to, make a straight line. What do the two angles add up to? Okay. Well, for linear pairs are supplementary, so they both do what? Add up to 180. What's complementary add up to? Yeah, not 180, but 90. Very good. How many of you watched the video on slide number 7? Hey, show of hands. The video on slide 7. Take a look. Okay, because if you did, should you know this at this point? You should. Guys, you're going to have to be a little bit more careful, okay? So page 1, all you have to do is identify which of those this is. Let's go to page 2. What's the difference between page 1 and page 2? What's the difference between page 1 and page 2?
Angle.
There's angles. So, for example, on number 11, how big is angle B? 71 degrees. How does he know it's 71 degrees? Because the other one is 71 degrees, and what's true about those two angles in number 11? Which one is it? Look right here. 3 choices.
Alternate interior.
Alternate interior. How long have you been in the class?
Like 30 minutes.
Okay, noted. All right, number 13. What's the angle of number 13? Somebody besides Mr. Lowe?
43.
You betcha. And tell me why. You got a 1 in 3 chance. You got a 1 in 3 chance for why B is 43.
Alternate exterior.
Now, air high five. Ready? Okay, good job. Now, so can everybody do 11 through 18? All right, I need you to write at the top of the page. I need you to write something. You ready? I need you to write the word why. W-H-Y question mark. W-H-Y question mark. So not only do you have to tell me what the angle is, you have to tell me why. Okay, good. If you don't tell me why, you don't get credit.
I like this guy.
Well, good. That it wears off. All right, now, 21 to 24. 21 to 24, what am I going to do here?
On the value of it.
Find the value of x. I think that's reasonable. Now, here's my question, number 21. Number 21, which type of angle is number 21? Number 21, which type of angle?
Corresponding.
Man, he's all over it. It's corresponding. Why is it corresponding?
One's on, they're on the same spot.
Because they're in the same spot. I like it. So, but here's the thing, guys. For this, you're going to have to do a little bit more. You're going to have to say 81 equals 4x plus 1 because of corresponding angles. Then what are you going to do? Minus 1. I agree with you 100%, sir. And so what reason did you get for this? How did you get here? Give me a reason. What would you just do? By subtraction. Now what's next? Oglesby. 20 equals x. That's by what reason, Oglesby? That's it. Yeah. Whatever you do, that's the reason, right, guys? Now, technically, shouldn't you switch these around and say this? By the symmetric property that we talked about last time. Technically, you should. I don't care that you do that, okay? You can stop right here. Is that all right? So, for 21 through the end of the packet, for 21 through the end of the packet, put proof. So put the proof right there beside number 21. Because statements and reasons is a proof, and you have to do it for the rest of the packet. Am I clear?
Yes, sir.
Okay, so does the next page look really any different? Does 25 through 30 look really any different? Not really, is it? And 31 to 34, does that look any different? Okay, so can we do this packet right here? All right. Let's go to the other packet. Now, next packet. What am I going to have to do, guys? What's the first thing I do? Read the directions, tell me what to do here. Okay, so I'm finding an angle, right? Oh, not B, dummy. There. All right, what can I label first? Top angle, bottom angle, or big angle?
Top.
Mm. RQZ, that's the one I don't know. Right, it says RQZ, find it. CQP is 30. RQP, so the whole thing is 121. How am I going to find the missing bit? That's it. Can everybody say 121 take away 30? Can we do that? Now, ladies and gentlemen, why did Mr. Moore give you printed out pages for the last section and for this one? What if I because these are online. If you go to your slideshow, these are online. What would you have had to done if I just left them online and didn't print these for you? What would I make you do?
Write everything out.
That's it. So aren't you glad that I at least wrote this out? So all you had to do was put in 30, 121, and
91. Oh.
91. Very good. Went the wrong way. I think you're right. I was wrong. You're right. Okay. So can we do that for each of these? So we can do that for this page. Next. Okay, look down at number 7. Look down at number 7 through 12, etc. Okay, is this just like the ones we just did on the last page, except now we have way more choices, correct? How many choices do we have here? He says 7, you say 7? There's 7 choices here. All right, take a look at number 7. What two angles, A and B, are what in number 7? Are they alternate exterior, alternate interior, corresponding, adjacent, vertical, linear, pair, complementary? You know what? He's not entirely wrong. Are they adjacent? Are they literally right next to each other? If you put that, you would be okay, wouldn't he? Is there another one that this could be? What is it, Isabel? It could also be linear pair, so you're both right. How is it a linear pair? Because do angle A and angle B make a straight line? That's it. How do you remember linear pair, guys? That's it. It literally is in the name, isn't it? It's literally in the name. Okay, what kind of angles are number 8? You're going to go to adjacent again? Okay, now, here's why you're half right and half wrong. Are they adjacent? Are they right next to each other? They are. Do A and B, is that enough to make a straight line? It's not in this case, is there? Complementary adds up to 90 versus supplementary, which adds up to, when in fact for number 7, could we also have gone with supplementary? How come we could also go with supplementary for number 7? Because did it make a straight line? And is a full line 180? Okay. So do you get the idea here? Hello? What's that? 8. 8 was adjacent. Sorry, adjacent. But it's not linear pair because it doesn't make a straight line. It's not supplementary because it doesn't add up to 180, right? Okay, hey, how about number 22? What do you think, number 22, Rambo? Complementary because they make 90 degrees. That's what the little box means, doesn't it? The little box means 90 degrees. So we can do that. That's easy. Uh-oh. Uh-oh. Turn to page 23. Oh, no. Now, here's a real quick question for everybody. Ready? How many degrees are in a full circle? 360. Do we agree? Okay. Why is that important for number 23? Because those 3 angles together make a full circle. So what would you do for your proof for this one? Because from 23 on, you have to do proofs. Are you ready? Whoop. Statements, reasons. Okay, here we go. What do I write for number 23? 360 equals 6x plus 3 plus 31 plus x plus 2x plus 11. Because think about it. If I'm starting right here And I say the whole thing's gonna be 360, and I go 6x plus 3, 2x plus 11, and 31 plus x, does that put me right back where I started? That's it, isn't it? What's the reason for this? This one, I don't think I've actually given you a reason. I asked you, is it full circles, how many 360 degrees, right? So what's our reason?
It's a circle.
That's it. Definition of circle. Wouldn't that make sense? Definition of circle.
Slide 12 is helpful.
Is slide 12 the fact, are they big fat worksheet things? Yes. That's it. Okay. So now what would step number 2 be here, Graven? What would you do now?
I know what to do, I forgot what it's called.
You don't have to know which called, just tell me what to do.
All the X's out.
That's it. Can I put this X together and that X together and that X together and call it 9X? Can we do that? Then what else could I do? Could I put those together? Is that okay? Now, help her out with the name. Help her with the name for that. What do we do? Remember, guys, math people are not creative. So if they're not creative, what do we call things? Okay, I like it. She says adding like terms.
Combining like.
Add like terms. I could totally go with Mr. Lowe's. Combining like terms. Would both of those work?
Yes.
Okay, again, guys, it's not rocket science. What did you do? I subtracted. What's the reason? Subtract. What did you do? I combined like terms. So what's the reason? Combine like terms. Okay, then could you keep going from here and finish solving this and give reasons for it? Could you do that, guys? Okay. Hey, what's the answer to number 27?
Oh,
54, because? Oh, no, there's no parallel lines here. What? Vertical angles.
Oh, I really.
Got it. You're working too hard here, boss. So, ladies and gentlemen, 23 and 24, proof or why for the rest of the packet. Proof or why. Now, how come there's no proof required for 27? Well, there's nothing to do, is there? You just say, hey, angle B is 54, correct? So that's just a why. Now, is there something to do on 29? There is. So I ought to see about 2 steps there. Keep on trucking. What do you notice about 33? Somebody tell me something about 33. It is adjacent. Can I do better than adjacent? Linear pair, linear pair, linear pair. So what would be true about 65 plus B? That's it. So you say 65 plus B equals 180 by linear pair.
Oh.
Correct. That's it. Okay. That's the rest of the packet. When does that due? Thursday. Okay, due Thursday. What?
I thought we were in here on Thursday, but.
You are.
Yeah?
Oh, you're not in here on Thursday. Still do Thursday. All right. Wednesday, we will take a look at the previous worksheet that we started our morning talking about. So parallel and proof.
After, when you do the distance formula, whenever you get it down to like the last thing,
Uh-huh.
you just leave it like that? or-
You have to reduce it when at all possible. But like, say it comes down to square root of 29. If it's square root of 29, can I reduce that at all? No, not at all. that make sense? Come on, little buddy. There it is. Okay. All right. So, ladies and gentlemen, you need to make sure you know these slides. Inside, outside, upside down. We'll talk about this one tomorrow. This is what you're working on right now. Okay, but how come you are thankful that Mr. Moore printed these out? Now, I told you these are due Thursday, right? It says due Wednesday. Let's do this. Thursday, but for you guys, I don't see you till Friday. Is that correct? I am not gonna have you submit them electronically. How come? How many pictures would you have to take to turn these in? Bunches and bunches, make sense? So here's what we're gonna do on Friday. I'm gonna come around the room while we're doing other things, and you're just gonna show me that you got them done. Does that make sense? Okay, so that's how we're gonna turn these in. So I suppose technically, like, well, so I could wait till Friday? I guess technically, if you wanted to, you could. But what's coming up, guys? Test. That is definitely not due Thursday. Let's go. Let's go Monday. Okay, so do you have plenty to work on today? Okay. Additionally, though, for those kids that did this yesterday, they had almost one whole packet done.